Hello and welcome everybody to the April 2025 edition of the VJug Live. My name is Kim Fletcher and I'm one of the VJug organizers. If you are new to the Virtual Java User Group, welcome. We are a global community bringing high quality tech Java talks and speakers to you from all around the world. For today's live session, please drop your questions and comments in the chat so we can get those answered for you. And if you are watching this after the live stream, please head over to our Slack channel and drop your questions there. This is also the best place to interact with the community and our speakers. So, now for the important bits. Let's welcome your host, Ishal, and Tom. Welcome. Hello. It's so good to see you all.
Oh, hello. I'm already breaking down my desk, apparently, so off to a good start.
Hopefully that's not going to be a theme throughout.
Who knows? The night is young, right?
Awesome. Well, the stage is yours. Take it away.
Well, I'm super happy to be here today with you, Tom, and I hope that we get to do this in our own jobs. Like, I'd totally be thrilled to have you on the Basel job. And whenever I'm in Belgium, I'm totally visiting you.
Yeah. You should come because we have these nice stickers that I was trying to pick up earlier, and then I knocked part of my desk down, so I'm not going to touch my desk anymore besides my laptop, I would love to have you over because we had Andres a while ago, and I was actually asking, is Ishal coming as well? And I was a bit disappointed that it was just him, if I'm honest. So
I know. Well, when you come to the Basel job, you will get, like, we have the Swiss Army knife as a present for our speaker. So listen to everybody. Like,
don't come by airplane. Don't come by airplane. Yeah. Okay, got it.
Or the bottle, the water bottle. We have thought about that. Like, for the speakers that are traveling just for the day, we have the water bottle.
Good to hear.
Yes. So, Tom, we're going to talk about a fascinating thing. At least it's for me. First of all, we're talking about a very important problem. Scheduling, planning, and trying to do it in a well-optimized way, which is the keyword there.
Exactly. Optimize is something different than just automating a schedule, but I'm sure I'll get to that somewhere in the presentation.
Yes. No, I'm super interested on seeing what you're going to tell us about, because it is a problem, or it is something that touches everybody's life. I mean, between scheduling, even sessions at conferences or planes or whatever, it is super important.
The second thing, a big reason why I switched companies and can now work on this full time, because I really believed, like, this is such a big problem. We can do it in Java, but nobody's really, everyone's focusing on something else right now. So
yes, and and that's the part that also is super important for me. I mean, this is something that touches our lives completely. And if we are doing something to optimize resources, that is when I think we're doing a good thing beyond solving a problem with technology. I think when we're focusing on this, on constraints and finding the solution, and on cherry on top, we're talking about a deterministic solution. Nowadays, everything is like, you don't know how this magic's happening.
Yeah, correct. It's not a black box. You can still explain what's happening, but it's still adding a lot of value. It's still AI. But yeah, some people don't consider it AI, but I'll come back to that in just a second.
Okay, so please, I'm super happy to read on any questions that there are posted on our chat or on Slack. I will pay attention and I will interrupt or try to make this as lively as possible. So the stage is yours, Tom.
Okay, perfect. So one thing about this room that I'm standing in, because it's been a while since I did a presentation from my home, this is normally the place where my cat sleeps. And I was like, maybe I can, drag the cat into this somehow. But Kitty said no. Can you share my screen?
Yes.
So my joke's already disappeared now, but Kitty said no. So I tried to pick him up, didn't work. But I must say, I'm really a cat person. Are you a cat person, Michelle?
Dog. Sorry to disappoint.
Well, the internet disagrees with you because cats is officially cats have taken over the world with all these cat pictures, and I'm very happy that with GenAI we can have as many cat pictures as I want. For example, a cat sitting on a crocodile while playing a banjo, boom, there you have it. A cat doing a comedy show in front of impressed goldfish, boom, there you have it. So the internet, as full as it already was, we can now add more stuff that sparks joy. And for me, cat pictures spark joy, of course. And honestly, I've gotten to the point that I go to so many conferences that sometimes in Dutch, we have this expression, sending your cat, which means don't show up anymore. That I actually wanted to maybe actually send my cat to a conference, and then maybe people could be delighted by my beautiful cat that speaks. You see, I really think that GenAI is awesome. So whatever I say during this presentation, GenAI is awesome. It's awesome technology. You can do cool things. I make a joke about cat pictures, but it has shown a lot of value already. But what I'm seeing online now is that people are pretending that it's sort of the solution for everything. At least the hype people are kind of hyping it up like, oh yeah, this will solve everything. We're all going to lose our jobs, yada, yada. And then I'm so contrarian. I'm like, why? Are you sure? Is it? Now, I do meet some people that are so into this hype that they always go like, yeah. You don't question it because we have RAG. And with RAG, we can add more data to the LLM. We can fine tune a model. We can do engines, and it will only get better. That's the main thing that I often hear. It will only get better. And that kind of destroys any argument that you could make against or push towards LLMs as a whole. So what I found really interesting is what is something that LLMs can't do. One, job security. To be a bit silly, if it's something that LLMs can't do, then we still have a job. But the second thing is really when there's such a hype going on, and we saw this with microservices a while ago, it's very important to know the strengths and the weaknesses of these things. So one thing that these LLMs can't do is solve planning problems. And like you said, Ishel, there's a couple different planning problems out there in the world, and they're actually everywhere. For example, one of the things that needs to happen almost every day, if you order something online, someone needs to deliver that package. And if you have 100,000 packages that need to be delivered and you have 20,000 vehicles, what is the best way to load in these packages in which specific vehicle so you don't travel too much? That you don't have one truck zipping all over the place, but that it's optimized in a good way, like the right selections are made. Another example is an airport. And actually, an airport has multiple examples of these kind of planning problems. The crew needs to be scheduled, and that's actually sometimes a tricky schedule because these people live somewhere. When you go on an airplane, those people actually don't live on the airplane. If they live in Belgium, they maybe take a flight to Basel and then have to take a flight back because they like to end up in the same place. Like planning all that stuff is very tricky. You also have the maintenance of these airplanes. There's a ton of stuff, a lot of planning that goes on right there. And then there is doctors. Like we have standard work schedules, and for example, nurses needs to be scheduled. You don't want a night shift to be without a nurse because that's just not a good vibe. And this one's a bit more personal because one of my neighbors actually does the scheduling for one of the hospitals. And, I was all hyping about LLMs and going like, oh, yeah, have you looked at ChatGPT? And basically she told me, yeah, but I have to do this. This is a very simple example. I have a few employees that have different skills, and then I have a few shifts that need to be filled in, and these shifts require different things. For example, the early shift here needs someone that can do intensive care. Yeah, in the example here, only Anna and Carl can do intensive care. Late shift needs an emergency room skill. So there's these constraints that need to be taken into account. And basically, this was a simple example. Often you have like 7 days, 5 shifts per employee. You have 30 employees, not just the 3 that I showed you here. And you have to assign 150 shifts. And while you're assigning these people to the shifts, you have to take into account certain constraints, skills. Do these people have the right skills? You don't want a nurse to do heart surgery, unless if they're also able to do that. But often nurses, well, on average, nurses are not capable of doing heart surgery. There needs to be time between shifts and so on. So there's a couple of constraints that need to be taken into account. And this neighbor basically asked me, Tom, can LLMs do that? And I was like, yeah, you know what? I'm very experimental. Let's just try. Let's see what happens. And honestly, from what I've heard online, I thought this would be a walk in the park. A schedule is just a CSV file. CSV is text. Thus, LLMs are good at text. Thus, it should be able to solve this. So I started running this, and I have a few screenshots of one of these reasoning models, because the old school LLMs that just put out the next token, that didn't make any sense. But these reasoning models, they reason like humans. So I was like, maybe those reasoning models can do it. I'm going to show you a few examples, because in some cases it was reasoning for 25 minutes. We don't have that kind of time to do it live. So I'll show you a few of the screenshots that I made. And the first observation that I had was a lot of Python. It is using a lot of Python to analyze the data that I had sent it. But it is finding valuable things, like in the data set that I sent it at 3 shifts, 5 days, 45 shifts. And it can even detect things in the data that I send it, like, oh yeah, Dan can't work Thursday or Friday due to unavailability. So it is actually finding valuable information out of that data. Then it starts reasoning, like, oh, I noticed that some shifts need certain skills. And in the data set that I provided, there were 3 skills. Ambulance, you need to drive an ambulance and run around. ORL, which I don't know if it's a term in English, but it is nose, throat, and ears. And surgery. So these are the 3 skills. Then it started reasoning a bit more. And then it suddenly started talking about Orlando. And I was like, Orlando? Where did that come from? Well, if you look at the previous example, it found as one of the skills ORL, but ORL is also coincidentally the Orlando airspace airline code. The airport code. So it was already mixing up a bit weirdly. Then it was very enthusiastic. I mentioned to manage rule 6. But for those that paying attention, I had entered 5 constraints. So it made up a new rule that the schedule had to take into account. And you can laugh at it, but I was actually quite impressed, because if you look at the rule that it added, it says here, avoiding a night to day shift. So it added an extra rule that I didn't put in, but it's saying, you know what, in general, you don't want to have a day shift right after a night shift, because then there's not enough sleep. So not what I asked for, but it kind of makes sense. And in the end, it actually came out with a schedule. And I was quite impressed. But then I did what developers usually do. When you have a complex problem, you try it on a very small subset of the problem, and then you try a bigger set. So on a very small subset, it was actually able to generate some kind of schedule. But then the question is, if I scale it out to a bigger data set, does it still work? Because you might make the assumption that if it works on a small set, it will work on a big set. But can it work on a realistic set? So the answer is no, not really. I'll show you some examples of what happened. So in some cases, the LLM, I tried different things like ChatGPT, Gemini, a few local models. Sometimes it just said unable to display the message due to error. What is an error? We don't know. It's a black box. In some cases, it did something really fun, and I call this the trust me bro output. Trust me bro being, don't worry. I have the output continues for all the other shifts, but I cropped it down, so I'm not giving you the actual output. I'm just pretending that I'm giving you the output. So that's like, trust me, I have it, but I'm not going to show you. And then finally, I was actually quite surprised, because some of the LLMs actually told me it's done. I have assigned all these 150 shifts under the constraints. We're finished. And I was very proud, and I thought, wow, these LLMs can actually do way more than I expected. Now, well, I think by now we all know that LLMs sometimes make stuff up. So I decided, you know what, maybe I should try to visualize the schedule, because it gave me a JSON of who to assign to which shift. So let's visualize it. And let's say it was slightly over optimistic, because this was the schedule that it generated. So in case you don't know, to give you some context, this is a short visualization of the schedule it generated. If your name is Amy King, tough luck, you're going to work a lot of shifts. And when the background is red, it actually means that they're having to do a shift when they're unavailable. So they're actually on a holiday or a scheduled break, and they have to work. Not that good. And the red ones, like you can see here, critical care, this is cardiology. And if it's red, it means that this person is assigned to a cardiology shift, but doesn't have the skill for cardiology. So if you need to have heart surgery, I hope LLM didn't schedule your doctors, because you might get one that doesn't have the right skills. So it's overly optimistic when it says that it actually succeeded. So what I find very important is that whenever you see something technically fail, is ask, why do LLMs fail here? Like, why is this not working? And one of the reasons why this isn't working is scheduling is not a sequence of decisions. Now, maybe someone else was yelling, context window. The context window probably is too small. Context window is, if I look at the evolution, probably a short-term problem that will be fixed pretty soon, because these context windows are getting bigger and bigger. This is really the root of a problem. What does that mean, it's not a sequence of decisions? Well, let's say we're human planners, Ishel. How would you approach planning these three?
Well, first of all, I will compute all the possible commutations and permutations, and then that honestly sounds like brute force. And then I check which ones are not compliant with our constraints. But then we have soft and hard constraints. So there are constraints like, I prefer not to work on my birthday, but if you are the only one, then tough luck for your birthday. So you see, but you cannot work a shift if you don't have the skills. That is a hard constraint.
Correct. So there's different levels of constraints. Maybe you don't want to work. That's like a soft constraint, more like a preference. And there's hard constraints, like you do not let someone who's a nurse do heart surgery unless they actually have the skill for cardiology, But you're a technical person, and I can tell, because you're like, oh, I'm going to write a script to just brute force this. Super cool. But let's imagine that you don't have a PC for a second. And actually, a lot of these things that we see in the wild are actually done in Excel or even on paper still. Like my neighbor is doing it in Excel manually. And manually, you don't brute force. But one of the things that you often see is that, oh yeah, but then I'm just going to go left to right. I'm first going to assign that first shift, that early shift. So let's try that. The early shift needs intensive care. So the first one that has intensive care, I'm going to assign it to Anne. Okay, good. Whew. Let's try the second one, the day shift. It needs oncology. Let's assign it to Beth. Beth has the skill oncology. Good. Now the last one, we have a bit of a problem, because the last one we want to assign it to Carl, but Carl doesn't have the skill. So now we actually have to backpedal and see, like, how do we change this? And the solution here is pretty simple. You switch these, and the schedule is done.
Well, you probably have had this problem. I mean, we are part of the JOGs, and we help organizing conferences. So we do have these problems when we're creating schedules. And then it goes crazy complicated. And for example, we have this message from Ed Burns. Ed Burns was traveling to Europe and was trying to create, like, let's talk to different JOGs, because I'm here, I can visit different JOGs, and then it is hard or sometimes impossible. And we're not talking about that particularly difficult problem, but what you were explaining, like backpedaling and trying to coordinate so much, sometimes is not great.
No, and it gets worse, because these are just 3 shifts to 3 people. This is like a toy example. So let's add like a little bit more of the toy goodness. So next day, 2 early shifts. So yeah, what do you do then? Okay, we assign these here because Beth and Carl are the only ones that can do oncology. So if those two need to fill in those shifts, then that's the only option you have left here. And then you realize, oh, but yeah, then Beth doesn't have enough time to sleep. That's maybe a problem. And by adding those extra ones, you actually end up with a solution that looks like this. So you have to switch everything around again. And you can still mentally do that with 3 shifts, with 5 shifts. But in reality, it's about much more shifts than that. So you can't just sequentially go, oh, I assigned this, I assigned that, I assigned that. Because these extra things are added, these extra oncology shifts in this case, and you have to reshuffle basically everything. So just doing it sequentially doesn't work. Now, I'm happy you mentioned brute force. So let's, because you talked about different combinations you want to try. So let's assume like a decent schedule is like 30 employees and you have 150 shifts that you need to assign. Like how many different solutions do you have then?
You know, Tom, I vaguely remember my math classes, and the keywords that are in my mind is factorial, permutations, and I know that those numbers are not small. When you're starting to add factorials, this goes to very, very far, very, very fast. So
Exactly.
I know this number is going to be like insanely big.
So let's look at, if we just try to assign 1 shift, we can assign 30 different people to it, right? We have 30 employees, we have a shift. So if we have 2 shifts, we can actually assign 30 times 30 different options to it. Why not factorial? Because those 2 shifts might be in different days, and then it can actually be the same person. So it is not 30 times 29, but 30 times 30. When you want to assign 3 shifts, you have 30 to the power 3. And now you can already see a pattern growing, meaning that if you have 30 employees and 150 shift assignments, 30 to the power 150 options. So people don't realize how big a number that is. So let me put that into context. Let's say, so 30 to the power, so that's 10 to the power 221. So let's take a moment to think about the galaxy and the universe. So the atoms in the observable universe, so all the atoms, all the grains of sand, like everything in the universe, it is estimated to have 10 to the power of 80 atoms. We're talking atoms. This number has 141 more zeros behind that number. So it is inconceivably large, the amount of combinations. So when you say, I'm just casually going to brute force it, the heat death of the universe will have happened long before a solution comes out of your heart, of your brute force approach. So you can't actually do that. And this actually also ties back into why LLMs are bad at this. You can't find a good solution for such a large space by predicting the next token, what's more classic LLMs were doing, nor by reasoning like a human, which is what these newer forms of LLMs seem to be doing. Like they reason, but if you look at the reasoning, the reasoning sounds very human, and that's just not what how you solve these kind of problems. So in short, no, LLMs can't optimize schedules. They just can't. But AI can, and this is sometimes surprising to people when I make this statement, because in the last couple of years, we've been talking about AI, and when we talk on the street to people and they say, I use AI, they don't mean AI as a whole, but they mean a very narrow, specific subset being GenAI. And GenAI, despite how cool it is and how many cat pictures I can have every day if I want to, it is not everything that's when you talk about AI. If you zoom out a bit on that AI circle, you actually come to things like machine learning, algorithms that allow computers to learn from examples. So I was zooming out on this AI circle and I thought maybe machine learning can be something, because, machine learning learns from patterns and it can make decisions. It learns from the data and then it can make a decision. So then the question was, can it do it? Because machine learning is awesome. Huh? Machine learning can allow us to train models that can recognize sign language Like it sound a bit, if you think practically how you need to use that, you need to use your phone and point at someone that's doing sign language. But anyway, you could do that, But can it be used to optimize schedules? Actually, no, because it needs to learn from data. And it will have a small margin of error, It will have even if you have 95% of the model correct, that 5% might completely change how a schedule has to look. Like as you saw, I added 2 new shifts and suddenly the entire schedule had to change. So it can't really learn from data because it's so specific. Today, one of the nurses is sick and not available. Next week is a holiday. Like, how are you going to train a model when it's so flexible, the data that comes in? And it's also about interlinked decisions. As you saw in the example, it's sort of like a Rubik's Cube, If you turn a Rubik's Cube and you think, oh, I'm almost finished with the perfect example, I just need this little square to go on the other side. You turn it and suddenly your entire thing is ruined again. So it is about interlinked decisions. So you can't really use machine learning for that. But even machine learning isn't everything that's in the AI circle. Artificial intelligence, the way that I found the definition online at least, is any technique that enables a machine to solve a problem like a human or better. And there is this subset within artificial intelligence that's actually perfectly made to solve these kind of planning problems. And that subset is often called mathematical optimization. And that's just a group of techniques that try to optimize a real function, minimize a real function. Now, I don't know about you, but it's been a while since I saw one of these. And it kind of scares me. And it kind of scares a lot of people. Like it's this strange language of math. And as much as you like math, not everyone is used to writing a model in a way that it is a function like this. So instead, I'm going to introduce you to something else today. And it's called planning AI. It's a fancy new AI term. And we will be using Timefold Solver for that. And Timefold Solver, you can compare it to something like JPA. JPA, the thing where you add annotations on a regular Pojo and suddenly you can connect to a database and get data out of it and it maps automatically. Well, Timefold works kind of the same way. All these fancy optimization algorithms are just domain code, so pure Java classes and then some annotations on top of it. And Timefold will do all the mathy stuff behind the scenes. So it's open source. It's Apache licensed. It's available in Java, Kotlin, and Python. Although I must say that, like many things in Python, it's a wrapper around what really matters. And in this case, it's Java. So our Python is basically a wrapper around our Java implementation. So I saw a question. I think it's already answered, but someone asked, how does Timefold relate to OptaPlanner? Timefold is a fork of OptaPlanner because OptaPlanner is not that well maintained anymore, and this is by the original creator and a big part of the original team that worked on OptaPlanner. So it is a real, true continuation. Simon answered that. Okay, thank you, Simon. So I don't like to talk too much. I know I've been talking a lot, but let's show some code. Actually, let me show you the example first. So let's say that we want to schedule 133 shifts. By the way, I must mention this. Everything I'm going to show you today, is in a quick start, so it is available without any changes in a Git repository. 2, Timefold is a solver. It doesn't come with a UI, but we added a very rudimentary UI for the quick start just so we can demo some stuff. So this is a schedule that we will be scheduling, just filling in. And these are the employees, and you can see some people have unavailable times. Some of them have skills and so on. So let's have a quick look at what that looks like in the code. So I did promise just domain classes, and I think I'm delivering here. So we have an employee that we're going to assign to a shift. Employee is basically just a Java domain object with some data, of course. You have the skills of the employee, when they are available, unavailable, only unavailable, because available is the inverse. When they don't want to work, undesired dates, like for example, I want to go with my daughter to the movies, but if I can't go, then my wife can still go. Just undesired. And then desired dates, like I have nothing else to do that day, just schedule me then, preferably. Then we have a shift, and this is where a bit more of Timefold will show. So the shift basically has an planning entity on top. So remember in JPA, I made the analogy, you need to put at entity. Here you need to do at planning entity, so Timefold knows about this. A shift has a start and end date, a location, and a required skill. And then the most important thing, it has a planning variable employee. And this planning variable annotation actually tells to Timefold, please try to fill in this employee from like a batch of employees that you have. So this is something that will change constantly while the optimization is running. So with that said, let's just run the thing. Now let's see what the result is like. How awesome is Timefold? Then you can see that there's immediately a problem. Would you consider this a good schedule, Ishel?
We have a lot of reds. No. And Elsa, poor girl.
Poor Elsa, right? I'm pretty sure I'm going to do it. I'm pretty sure she wants to let this go.
Yes, I don't think she would say
sorry.
that. Yes, let's continue.
Stupid Frozen reference. I'm pretty sure she wants to let some shifts go. Huh? So while Timefold is trying to schedule this, there's one thing I didn't show you yet, and that is we actually need to tell Timefold in code the constraints. What is it not allowed to do in this case? So since it has no constraints, it will just assign everything to Elsa and everyone will go up top. As long as you're not Elsa green, you don't have an issue. So that's good. So let's add some of these constraints, right? Because poor Elsa. So there's actually this thing called a constraint provider class. And let me just uncomment one of these. So here you can list all the constraints, and I'm going to uncomment the required skill constraint just to show you what such a constraint looks like. So I must say that when working with Timefold, this is the thing that will seem the most unfamiliar, because it looks a little bit like the Java streaming API, and it looks a little bit like a SQL syntax, but once you get used to it, it's very intuitive. It's just a bit unfamiliar the first time you see it. So what is this? You're basically going to select all the shifts here. Then for each shift, you're going to filter all the shifts where the assigned employee that Timefold has filled in that person's list, if it contains the required skill. If it doesn't, then you're going to penalize it with 1 heart. So that's 1 heart failure. And basically, we consider heart failures to be physically impossible, or you don't have a good schedule, a feasible schedule if this is happening. Like you can't have an employee that misses a required skill. So now that I've uncommented it here above, let's jump back to the schedule. Let's quickly refresh this, and then let's solve it again. And then you see that at least it's divided now. Like the shifts that require a doctor now, unfortunately, it's also Elsa. Elsa Lee is assigned to. So it's already distributed because those are skills that why is this the same name? Why Elsa Green didn't have gets assigned to Elsa Lee, and so on. So we, of course, can improve the schedule even more by adding some more constraints. So the typical constraints that we have in the hard category are like no overlapping shifts. You don't want a morning shift and an afternoon shift that mix 2 hours. That doesn't work. You need at least 10 hours between 2 shifts, 1 shift per day, preferably, and it cannot be an unavailable employee. So let's just solve this thing again. There we go. All right, now we're getting somewhere. So as you can see, now in just a few seconds time, Timefold has actually managed to assign all the shifts, but it can still be improved. What do you think could be improved here, Isha?
Well, first, why that would be my question. Why do you think it could be improved? Well, I have some red stuff like the ambulance, Lisa Lee and Elsa Green also have problems. But well, maybe you will continue with examples and you will tell me, I'm happy with this particular schedule. Right now, I see the problem. Totally.
Yeah, so, and that's what happens when people schedule manually. Often they stop here. They say, oh, the schedule is feasible. Like there's a few people that are working during undesired times, but it's already so complex to make the schedule. I'm just going to stop here, right? But that's actually the power of doing something like this with a tool like Timefold, because it isn't that much more difficult to add more constraints. So let's add some soft constraints. This means that we will try to take it into account, but if it doesn't work because nobody else is available, then too bad, so sad, basically. So let's try it again. So before you saw a lot of people working during undesired times.
Yeah.
Now let's look at the schedule again. And you can see that while it is running, it's still optimizing and finding better and better solutions. And the power, what I really liked about Timefold when I first ran into it, it's the more time you give it, the longer it will try to find better and better solutions, and it will always return you the latest best solution that it found. So if you only have 5 minutes to do the solving, you'll have a solution. But if you have like an hour or more for more complex cases, it might find a better solution still. Now, you can configure it that if it doesn't find a better solution in like 2 minutes, then it stops anyway, conserving energy a bit. But it allows you to give it as much time as you actually have, because once a schedule is only valuable if you get it before the time that it actually starts. If you get the schedule the 23rd of April, you get the schedule, it's too late because 2 days have already passed. So now there's one thing that I want to show you before I carry on, and that's we define these constraints, right? So we added them in code. But one of the things that I like a lot here is that it's actually explainable. Like if you click this, you get the score analysis, which gives you an overview of what constraints were added and how many matches were there, were there any problems, and you can actually talk to a business user like this. Oh, look, and you can compare schedules like this. Like the desired day. So in this case, we had 7 times a desired day for an employee, so that's a positive score, good. And we try to balance shift assignments, and there's a certain weight that's happening there. So you can actually compare these schedules by using business constraints, basically. As a business, you define the weight of these constraints, and then it generates a schedule. So explainable AI.
Transparent.
Transparent,
like, you can understand, and people can understand that it's the algorithm doesn't have anything against them. Like it's trying its best, and even if it's violating some of the soft constraint, it will tell you, well, it's not so often.
Yeah, exactly. And now this was a bit of a toy example, 130 shifts. Let's go large, right? Let's assign almost 1,000 shifts, so 964. So that takes a bit longer, of course. The bigger these problems are, the longer they take. But you can actually see it evolve in time. Now we have 2 hard constraints failures somewhere. Oh, one more. If I don't hurry up, it's actually finished. Oh, sorry. So you can see here in the explanation that right now, somewhere someone is missing one required skill. So that's why this schedule isn't the best schedule. And normally, if my CPU gives this thing enough CPU cycles, there we go. It is able to solve this in just, 30 seconds or something? So even this larger problem, it can be solved quite easily. And the fact that you can define these constraints just in Java code with your domain in Java objects and then having these constraints, it just floats my boat, let's say. All right, that was what I wanted to show for the demo. So basically, it's model your domain in Java, define and add some annotations to make Timefold work, define your constraints, and then run it. And then you have a solution to your planning problem. Now, I already gave 3 examples. Let me give some more. To answer Ed, yes, there's no LLM involved. This is purely Java. There's no extra process running. These are optimization algorithms written in Java that you can execute without actually needing to know much about optimization algorithms, because it's just annotations on your domain classes. So I hope that that answers the question. Now there's a few more examples, and I actually showed you an example from our quick starts repository. So these are all examples for which we have a quick start that you can just take out of the box and go play with it. The ones that I personally like a lot are the school timetabling, because I know a lot of schools, and my wife works in a school, by the way. a lot of schools spend so much time creating these schedules because there's these constraints as well, right? The classroom can only be used by one lesson at the same time. The chemistry teacher needs the chemistry room because things might explode, yada, yada. So there's a lot of good stuff in here that you can just pick up. And they're also Apache license, so you can basically do whatever you want with them. We also do conference scheduling, and there's a few conferences that actually use us to schedule their conference schedule, because that's also a very tricky one. What would be, I saw the question by Chitan, what would be some good resources to learn the maths behind the optimization problems? I don't have the list at hand, but if you actually go to our documentation, we have written out all the algorithms that we personally support and some details on how it actually works behind the scenes. Because while you just put an annotation on your Java classes, we actually have different algorithms implemented that you can just configure. So it's a lot like JPA, basically, where you add annotations and whatever database you want to talk to, you can change some properties. It's the same here. You can choose different optimization algorithms. We also at Timefold have a monthly newsletter where we talk about these kind of problems and just make people aware that these kind of problems are there and they can be solved with Java. So that might be a resource also worth looking into. So, question, does optimization matter? Because I get that sometimes, because we have seen automation, which means automatically creating a schedule, but then there's the optimization part. And optimization goes a step beyond. It is being able to tell to your employees, you know, you have a desired day that you don't want to that you want to work or don't want to work. We can take that into account because we have this automatic system now that can also optimize that. But honestly, it's sometimes a bit difficult to put like a real value on employee happiness, because that's basically what it is, right? Being able to tell to your employee, yes, you can have that day, no, you can't have that day. So let me give you another example, and I'll use a vehicle routing case where a bunch of packages needs to be distributed all over a certain location. You know, you have 100,000 packages, 2,000 vehicles. How do you divide those? So let me give you a concrete case. One company that used Timefold was expecting like, maybe I'll get 1% driving time less. You know, it can optimize with routes a bit. Maybe it's 1%, and that would be a giant win. 1% less travel time, great. It turned out to be 25%. Now, 25% is a lot less time in traffic. If you're more ecologically minded, it's also 10 million kilogram CO2 emissions less per year. And if you're more financially incentivized, it's also $100 million less per year. So that is something that using these algorithms can actually give you, optimizing these problems, basically. So if that doesn't impress you, then I don't know what will. So LLMs can't do this. I've shown you in Java, you can totally do this. And this is still part of AI. But what about the future of AI? And this is a tricky subject because future, I think 5 years ago, we thought that things like ChatGPT were like a decade away or more. So it's difficult to see. But let me show you what I think short term is the future that I foresee, at least. So we have these circles of AI. And I think the future of AI is one where we will see more and more integration of those different levels, where we see things like using GenAI in combination with machine learning, in combination with these more classical AI solutions like Timefold is one. And bringing those together will be the real win, not just LLMs, but the entire thing, bringing it together. So what could that look like? Well, the obvious one is, of course, letting the LLMs write the codes that then triggers Timefold. You know, that's like the most obvious one. We've actually been looking into how do LLMs generate our code, because it's important. We have a library that we want people to use. Like, I would love to just have a benchmark, like if you want to work with Timefold, use this LLM. So far, nothing really pops out, but we are currently experimenting with making our own GPT. And I just quickly want to show you what that looks like. So this is our GPT. How did we configure it? It's not public yet, by the way. This is a sort of private preview. You can totally tell it how it must react. So it must respond in a witty and approachable way, and it must refuse to answer any questions not related to Timefold, which it doesn't always do, but pretty well. And then we gave it a bunch of extra information on how to respond and what it should know. You're well versed, you know all this. And then probably most importantly, we gave it our 500-page documentation in PDF format. And we've actually noticed that the answers that this GPT gives are way better than the standard GPT. So if I ask here, could you write me a constraint which makes sure that a employee has the correct skills for a shift. So blah, blah, blah. So it's probably going to make some assumptions about the domain because I didn't explicitly say this is how my Java classes are set up. But it is giving a reasonable answer. It's using a bit more ceremony than necessary. It's using a bit of an old syntax, but it actually does explain all the things that you need to know if you want to work with Timefold. So this is something that we're experimenting with. It's not public for a reason because it's sometimes returning deprecated code, but that's what we do. And if you want to make sure that it doesn't ask anything else, so how do you like the weather in Belgium? Because I did ask it to please not answer anything that's not Timefold related. What do you mean famously fickle skies? What's this kind of diss? But as much as I like to riff on Belgium's famous fickle sky, my heart belongs to Timefold. So you can do some funny stuff with this. You want to keep going with constraints. So anyway, back to the session. So the second thing that we, of course, are looking into, like a lot of people are currently looking into, MCP. And for those who don't know, MCP is a way to expose certain pieces of code that you write in, for example, Quarkus, to an LLM. So let me just quickly show you how I did that. I typically use Goose for this. So Goose is a local tool that allows you to connect any LLM you want to it, even local ones. So I'm using Qwen now with Olama. So this is a fully local model. And I can ask it questions like, well, I've configured an MCP server that will allow me to set up the demo data for an security guard industry. There. And it will actually set up the demo that I showed you before, but instead about nurses, it will make all the demo data about the security guard industry. So it will try. So it's actually messing up here. I need 4 skills. Even though it's part of the MCP protocol, and I explicitly said, give me 4 skills, it doesn't always do that. So there we go. And it's asking me, hey, do you want to call this tool? So why am I showing Goose? Well, it allows you to set up a custom model instead of some other desktop clients. And you can set it up how you want it to interact with you. Do you want to be completely autonomous? Then it just calls tools and does whatever you want. I'm not that confident, so I would prefer that it asks me to use a certain tool. So I'll click Allow Tool. So
no
this is
YOLO
all
mode for you.
What?
YOLO mode for you. You only live once.
No. Yeah, I only live once, but YOLO mode for me is fine, not when I impact people by going rogue with AI. So I set a security guard industry, so I set it up. There we go. So it has changed the demo data of the demo that I showed before. So it's not nurses, it's now a shopping mall, office building, residential building. And the skills that it has set up is physical fitness, crisis management, surveillance, and communication. So things that I would expect a security guard to have. So by integrating with MCP, I was able to change the demo data on on our quick start. There's other ways to do this as well with LangChain4j, but fusing these powerful tools and add like Timefold and adding LLMs on top of it, and maybe in the future adding machine learning on top of that as well, that integration of those AI segments is going to be so much more powerful than just LLMs, and even more powerful than agentic, if you ask me. Maybe an agent can combine everything together, but I don't see that happening that soon. So for me, really, this integration of everything together is the future of AI, and not just GenAI, but AI as a whole. So I showed that. So where I think that these, when it comes specifically to planning, I think these different layers have their own strengths. So GenAI is good at data extraction or even explaining things.
Mm-hmm.
Machine learning is good at prediction, because in these examples, I still had to know how many shifts do I need, how many employees do I need, how many nurses do I need. If we can use some machine learning to predict that, that would actually enhance how this Timefold algorithms could work. Because that's something that Timefold doesn't figure out for you out of the box. Like, how many employees do you need? It does that a little bit by having shifts that are unassigned, but machine learning is really a great tool to have wider predictions. And then, of course, planning AI, and Timefold is one implementation of planning AI, is perfect for scheduling and solving these kind of problems. So before I go to conclude, let me just check what questions are starred. GenAI is not really good for strong constraints. Yeah, I think I called that one. What is the conceptual difference from OptaPlanner? I think I covered the conceptual difference is that it's a fork. So we forked it. The original creator, Geoffrey de Smet, started Timefold. As a good good post about that, why that happened. So I would look at that, but it's basically a continuation that's well maintained and very active. And then Jean-Christophe asked, can you actually do optimization problems that are not defined in these abstractions? And I don't fully get that question, Jean-Christophe. So if you could elaborate a bit more, then I'll try to get back to that later.
I think the question was most about, like, do I have to express the constraints in how you show us the constraints, the code? And because Lucas already kind of gave him the answer or the hint there, and saying like, yes, we do need to use this kind of model for the Timefold solver to understand what is happening. And so
yeah, okay. If Lucas answered that, then he's the lead developer of the solver, so I'm pretty sure he answered it quite adequately. And hopefully, I don't get any angry messages later that I said something on the stream that he doesn't agree with. But we'll see. We'll see afterwards. So I think we should conclude. I think don't get me wrong, GenAI is awesome, not just for the cat pictures. I think there's a lot of value to be had there. As well, and we're seeing it, and it's still kind of new, so we're still exploring like what could it mean for agentic workflows and all this new stuff. But it is awesome, but we still need to realize that it can't do everything, and that's something that I hear too much. Like, well, we don't need any of these other things. No more machine learning, no more AI. We'll just give everything to our LLM overlords and let them figure it out. I don't believe that. So, if you take anything away from this talk, it's this: when someone tells you, I'm working with AI, try to really be conscious about, are they talking about GenAI? Are they talking about the broader sense? And realize that there's a lot of value outside of GenAI that I fear we're kind of neglecting at the moment. Everyone is so focused on that GenAI part that we're sort of missing out on that other stuff. And by the way, GenAI, with LangChain4j and MCP, we can do in Java. Machine learning, we can do with deep learning for J, and other forms of artificial intelligence you can do with things like Timefold. So Java is really a really powerful language to do AI in, and don't let other programming languages overwhelm you like that. And it will only get better with future enhancements like foreign function and memory. It's going to change a lot of things, and Java is perfect for the integrations that are possible with LLMs now as well. So that was what I wanted to say. I've introduced you to Timefold Solver. It's a link to our documentation page. And yeah, any feedback is much appreciated on the VJug Slack. I'll be hanging out there for a while after this talk. And that was it, Ishel. That was it.
Well, thank you very much, Tom. And I agree with you. I mean, we have a very interesting future with all the combinations of the different versions of AI. And I totally agree with you. The most important part is going to be integration.
Mhm.
The other thing is, how do we make sure that the answers are correct? Maybe you later on will have a follow-up session about that. How do we test this? How do we, because right now it was a lot of visualization, et cetera, but maybe there are already things that you can talk about us, like how to double check that.
So, do you mean check what Timefold is doing or the LLMs?
Well, I will start like in different dimensions and orders. First, that the outcome is like be like, obviously you have the results that come with a degree of confidence, and you have it weighted towards it's a hard or it's a soft one.
Mhm.
But for example, the answer is, how long would it take to find the most optimal one? For example, that would be interesting to know. But as you said, also the testing side is, if the LLMs are doing the correct stuff, or the machine learning about predicting things. I have, for example, what you said, like if we're talking about a hospital and we're talking like, well, you have information about 100 patients, but what happens if we open a second building and we now have capacity for 200 patients? How many nurses do we need, for example, or things like that?
Yeah. I think when it comes to having the right answer, Timefold is deterministic. If I run the same example twice, as long as I get the same amount of CPU cycle is like, if my laptop's plugged in, it might take less time than when it's not plugged in, but you can run it multiple times and try that way. When it comes to testing the output, it's all Java code, so you can test the individual constraints from Timefold. And when it comes to testing and validating LLMs, there are new things popping up, like in LangChain, you have these guardrails that do it at runtime. And there's test frameworks coming out that have like, if it's 80% like this, then we make the test green, because we never know exactly what's going to come out. So there's a lot of interesting stuff happening there as well. And I will personally be exploring the combination of these three, like general AI, machine learning, and GenAI, and combining those will probably become a workshop in the near future. And then talk to people about it. Look, and all Java, of course, because why would I do another programming language when I can do all of this stuff in Java? So that will be coming up. I hope to get it done by Devox Belgium, but we'll see. And also have to come to Basel and do it there. So such a horrible idea, of course. All right.
That's fantastic. Thank you both so much. It was a really, really fascinating session, and some interesting comments and use cases that people have put in the comment section. So I'm also eager to start playing around and see what sort of schedules I can put together. So thank you both so much, and hopefully we will have you back with us on the VJug soon. And just a reminder to anybody else who is watching this after the live stream, please still do drop your comments and questions over in the Slack channel, and we will try and get Tom and Michelle and the rest of the community to answer them for you. And our next live session will be on the 28th of May, where we will be joined by the one and only Dr. Venkat, talking about extending functional pipelines with gatherers. So hope to see you all there. Until then, take care.
Take care, everyone.